Hi, I'm Lucy Alexander with AIChE, and I'm here with Dr. Vikram Rao, who is the Executive Director of the Research Triangle Energy Consortium. Dr. Rao, what role does methane play in CCUS discussions today?
Well, actually, it plays basically two roles. Natural gas being produced today is unusual with respect to the way it was before. Shale gas is highly distributed in nature, in the sense that each well will produce 1 to 3 million standard cubic feet a day, whereas in the past, a natural gas well was 50 to 100 times bigger than that. So if you want to monetize gas in some way by converting liquids, then you'd have to use some different technology than was previously available before. The other thing is that a lot of this gas is a bit stranded in the sense that there's no pipeline capacity for it, or because the price is so low that it doesn't get monetized. The other way is methane emissions, basically what we call fugitive emissions. Uh, there's been a lot of studying of that going on right now. But we do know that methane is being emitted by oil and gas industry, from waste dumps, and from agriculture, where ruminants emit methane. So these are the three principal sources of what we call fugitive methane, and they need to be handled because methane is 21 times as much a greenhouse gas as CO2.
Okay. And what are the technological opportunities associated with methane as a greenhouse gas? And how are these different from carbon capture technologies?
Okay, so the primary technology that one has to harness is the conversion of methane into something useful, and most of us believe that should be some liquid, and the easiest liquid is probably methanol. But the conversion of methanol from natural gas, from methane, is conventionally done in plants which are between 2 and 5,000 metric tons a day. But now we're talking about going to a location which might have a typical waste site, say from a swine lagoon, will probably produce 1 million standard cubic feet a day. So you need technology that would convert 1 to 3 million standard cubic feet a day into liquid. That is innovative because the current dogma would say that the scale is too small to be economical. So the principal technology for methane is small footprint conversion. CO2 is different, especially CO2 from air is different because it's ubiquitous. So it's not that it's distributed, but it's in low in concentration. So, so on the one hand, low concentration CO2 from the air is the problem with CO2, or low concentration CO2 from flue gases. Whereas with methane, it is not necessarily low concentration. It's not low concentration. It is just distributed all over the place. So the slightly different technologies are needed to execute what you need from them.
Okay. Well, thank you very much, Dr. Rao.
You're welcome.